Logic props are the brains behind your puzzles and interactive environments. These props don't appear in play. They're invisible to the player but work behind the scenes to control puzzles and events. They act as a visual interface for you, the builder, translating your setup into game logic, all without needing to learn how to code. You'll find logic props under the Logic tab in the game menu. In this video, we'll go over the logic props from the gameplay group. For logic props from the movement or visual audio groups, see our next video, Logic 2. So a lot of builders underestimate the empty, but they are one of the most useful logic props in the entire builder toolbox. They can be assigned all the same behaviors as a visible prop, but are completely invisible to the player. Let's go over some of the most common and powerful ways to use this incredible little sphere. To organize. Complex setups can get messy fast with props everywhere. Adding an empty as a parent to the setup can act like a folder to organize the props and a handle to grab them by. Moving the empty moves everything that is the child of it. Deleting the empty removes the entire setup. Duplicating the empty copies all of its children with their links intact. Give this master empty a clear and descriptive name, and you can then easily find it later using the search shortcut, which is Control Space. As a rotation hinge. So rotating props as animations, turnables, or dials always rotates them around their center gizmo. As you can see with this door, the gizmo is centered, but that's not where a real hinge would be. That's where empties come in. Place an empty at the point where you would want the item to rotate, the true hinge or pivot point. Then, set the door's behavior to none, make it a child of the empty, and set the empty's behavior to animation. When the empty rotates, the door opens naturally from the correct hinge point. This same trick works perfectly for turnables and dials. Fixing item orientation. So sometimes items look incorrect when picked up or carried. Too big, too small, backwards, or covering the player's camera. You can fix that using an empty. Add an empty at the spot you want to be the center of the item or carryable, and make the empty an item. Then, make your visible prop a child of this empty and set its behavior to none. Now you can fine-tune the visible prop's position, rotation, and scale relative to the empty, adjusting how it appears when held, carried, or viewed in inventory. Just be sure to rename the empty to match the visible prop's name for when the player goes to interact with it. This same trick also helps align all keys correctly for slots. See the slots section later on for more on that. Item respawn point. Place an empty at the exact spot you want an item to appear when using the item respawner. We'll cover item respawners later in this video. Invisible buttons. So sometimes you want players to have a clickable interaction, but without a prop, more like a hotspot than a physical button. Adding an empty button with a collider as a child gives you an invisible interaction zone. Prop scaling issues. Sometimes adding children to a prop that has been scaled and rotated can cause the children to appear stretched or skewed. To preserve proper proportions, add an empty, keep its scaling uniform at 1, 1, 1, and make all elements of the prop the children of that empty. Stacked animations. Sometimes one A-B animation just isn't enough. For more complex movements, you can use an empty as the parent of an animation and give it a second animation. So for example, I'll move this sphere to the left as its animation. Then I'll add an empty, make it the parent of the sphere, and give the empty its own animation, moving it forward. Next, I'll set the sphere's animation to trigger the empty when it reaches its waypoint. So now when we play it back, the sphere first moves left, then triggers the empty, which moves it forward. This kind of setup lets you chain multiple animations either simultaneously or timed using delay logic, which is covered in the next section. You can make the animation chain even more complex by adding additional empties as grandparents or great-grandparents. Add an animation to a prop that cannot be animated. So some things cannot be animated, like colliders, obstacles, and triggers. In order to animate these things, you can always add an empty as the parent and give the animation to the empty instead. Delays let you add a timer before an event occurs. You can set the number of seconds to wait, then add the actions you want it to perform when the timer completes. Activating the same delay a second time starts a new timer and adds its actions to the queue, but it won't cancel the previous one. Setup logic lets you specify actions that should run automatically when the game starts. Some props will have their own individual checkboxes for active on start, but using setup logic is a clean way to consolidate all of these actions in one place. Triggers are invisible 3D boxes that detect when a prop or player enters or exits them. You can then attach actions to those events. You can configure a trigger to react to any prop or only specific props you select, react to any player, or only once all players are inside or outside the box. Checking the box for is sticky means that the trigger can only be used once. There are 4 main trigger events you can connect actions to. Start. When the first valid prop or player enters, meaning the box goes from empty to no longer empty. Enter. Every time a valid prop or player enters the box. Exit. Every time a valid prop or player leaves the box. End. When the last valid prop or player leaves, meaning the box goes from not empty to empty again. Trigger events fire as soon as any part of the prop or player makes or loses contact. Slots are used when a player must place an item into a specific location. Slot keys snap the ghost outline of the prop to the slot, indicating that an item can be placed here. This could be something like inserting a key into a keyhole, or placing a statue onto its matching pedestal. For each slot, you'll choose any correct keys, the item or items that solves the slot, any reject keys that should still fit in the slot but not count as correct. This is useful for puzzles like a lock with 4 keys, but only one that works, or a set of statues that can be swapped around until the player finds the correct arrangement. Click the key placement button to align how the prop should appear when placed in the slot. Like animation waypoints, key placement responds only to position and rotation, not scale. Control what happens when a correct or reject key is placed. Stays in slot keeps the item parented to the slot so it can be picked up again. Eject to inventory returns the item to the player's inventory. Merge with slot merges the item into the slot, disabling both key and slot from future interaction. Eject to world animates the key into the world in the indicated animation direction in the 3 boxes below using physics. You have these same options for when a reject key is inserted. Merging reject keys with a slot will potentially prevent the player from solving the puzzle. If your reject keys are visibly misaligned when placed, making it obvious which keys are rejects, you can fix this using the empty orientation trick mentioned earlier in the Empties section. Align all your key props in a neat row and set them to none. Add an empty at the center of the first prop and make it an item. Press Ctrl D to duplicate and move them horizontally to the next props. Parent each key prop to its empty and rename the empty to match. In the properties of your slot, make the empties your slot keys and reject keys. You can also select a prop as the initial key. It will start already slotted. When Rotate Key is selected, you can choose how the key animates when inserted. Choose positive or negative values on the X, Y, and/or Z axis to control rotation direction and count. You can combine these for complex animations. Once an axis is selected, turn duration is how long it takes to complete one full animation in seconds. Turn count, how many animations the key makes. Note, the onPlace event only fires once the key animation finishes. If you want a short delay after key placement, set all axis values to 0. The animation will still play for the animation duration you set, but without motion. You can add actions for when the correct key is placed. These will play after whatever animation you have set. If you want the slot to react to reject keys, in addition to correct, you can place a trigger in the same area as the slot and use its enter and exit events for custom responses. You can also set actions for when an item is removed from a slot. These apply to both correct and reject keys. For this example, I'll have my key rotate once on the x-axis, taking 2 seconds, then trigger this door to open. I'll also have my key merge with the keyhole once it's placed. Because my slot is for the keyhole on the door, I should add my slot as a child of the door so it moves with it. Let's test it. For a trick on using slots to make an item constantly rotate, see our tips and tricks video. Locks are the logic prop that builders use to set up and recognize winning conditions for puzzles. You'll give the lock a password, and then route all of your puzzle's player interactions through it. When the lock detects the correct password, it unlocks and performs its on-unlock actions, like opening a safe once the dials are set to the right positions. The password you assign to a lock is a series of numbers. A lock starts out the level with its password reading null, or all zeros. Then, player interactions and events send new numbers to the lock. For example, when a player steps inside a trigger, or presses a button, or places an item in a slot, or turns a dial. As the builder, you define both the password for your lock and the numerical outputs each player interaction sends to it. For binary interactions, which is to say things that can either be true or false, your lock's password might be as simple as a series of ones, where 1 means true and 0 means false. For example, if you have 3 statues that must each be placed in a slot, the correct password might be 111, meaning all 3 slots report true or 1. For keypads or number-based puzzles, the password often corresponds directly to the numbers the player enters in the game world. For example, pressing 911 on a telephone would probably send the password 911 to the lock. The lock password consists of indexes and the numerical variables you assign them as the password. A password of 111 has 3 indexes. A password of 90210 has 5 indexes. You, as the builder, enter each index of your password into the boxes displayed in the Properties pane of the lock. You then connect a prop to the index of choice when connecting to the lock. Some special indexes to note when connecting to props. U unlocks the lock immediately. This is useful for playtesting in the editor or allowing players to skip a puzzle. R resets all indexes to 0. We will go over the other uses for display logic in its own section, but it is incredibly helpful for debugging locks. It can automatically show the current password a lock is reading during gameplay, like a password monitor. This lets you quickly see puzzle solutions as interpreted by the lock. To do this, add a display logic with as many columns as you have password indexes and connect it to your target lock. Locks can receive inputs and read indexes in different ways, depending on your puzzle setup. The separate input type connects player interactions to specific indexes in the lock's password. So for example, if you have 3 statues on 3 pedestals, each slot targets one specific index of the lock. A safe with 3 number dials would also connect each dial to one index of the lock. So essentially, each index is checking whether the connected slot has the correct key or the connected dial is set to the right number. With a sequence lock, inputs aren't tied to specific indexes like with separate locks. Instead, all inputs connect to a single generic asterisk or star entry point, and the lock continuously evaluates incoming numbers, remembering the most recent inputs. For example, if the sequence requires 3 numbers, the lock always remembers the last 3 numbers entered into the sequence. When you enter a 4th number, it replaces the oldest number in memory, so the buffer continuously updates with each new input. These locks are used for keypads or locker combos where the player enters a series of inputs in sequence. For example, if the password is 911, entering 911 unlocks it. Entering 34911 also unlocks it. Entering 274911 will unlock it as well. And that's because it's always waiting to receive 911. Even if the password seems out of order on the display monitor, remember that a sequence lock can loop around to continue reading back at the beginning. This will not affect the password that you enter into your lock. Resetting sequence locks operates similarly to sequence, but with one key difference. Once all indexes have been received, the lock resets all indexes to 0. Using our previous examples, 911 works. 34911 does not work. Once the lock receives 349, it resets, leaving 110 as the final input. 274911 works because after 274, it resets, and then it receives 911. For resetting sequence locks, it's crucial that the player knows where they are in the sequence or if it's been reset. This feedback could be playing an error sound or flashing a red light when the password resets. More commonly, you would display the current password to the player using a display logic prop, similar to what we've done here. For most puzzles, you will use the AND logic type, which means that all indexes must be correct for the lock to unlock. For some more advanced puzzles, you can choose other logic types, which we'll display here on screen. Or, one or more of the indexes must be correct. Exclusive XOR, only one index can be correct. Parity XOR, there must be an odd number of correct indexes. These other logic types are almost exclusively used with separate locks. Some additional options for locks are negate, reverses the logic, unlocking the lock when the password is incorrect. Disable on unlock, which prevents the lock from receiving more inputs after it unlocks for the first time. Exit zoom on unlock is useful for puzzles solved while zoomed in on an inventory item or zoomable prop. When the lock is a child of that prop, this ensures the player automatically exits zoom once the puzzle is solved, allowing them to see events in the room around them. Finally, every lock includes on-unlock and on-lock events, which you can connect to other events, but keep in mind that a lock can only unlock from a locked state, and vice versa. To understand how player interactions send numbers to locks, let's revisit some of the behaviors and logic props we've already covered. Interactable props and logic offer event actions, letting you define what happens when they are activated by the player or by other props. So let's create a simple sequence lock puzzle. So for this puzzle, we're just going to set up 3 buttons. They're going to send to the lock and unlock the lock once the correct sequence is sent. First, I'll add a lock, and I'll set the password to 123. I'll set the lock to sequence. To monitor the password, I'll add a display with 3 columns for my 3 indexes. I'll set the on-unlock action to play an animation. Then I'm just going to duplicate this button twice so I have 3 buttons. I'll connect each button to the lock on press. You can see that as soon as you connect to a lock, the output value property on the button appears. I'll assign output values for each button. On button 1, I'll give an output of 1. On button 2, I'll give an output of 2. And on button 3, an output of 3. So my first, second, and third buttons send corresponding outputs to the lock. Now, pressing the buttons in the correct order, 1, 2, 3, updates the display and unlocks the lock. You can also test with incorrect sequences first, and the lock will continue listening for the correct sequence and unlock once it's entered. Now let's set up an example for a separate lock. In this example, I'll use a dial to send outputs to the lock. When connected to a lock, turnables, dials, and slidables send outputs each time the player moves them into position and then releases them. So here I have 3 dials set up. I'll set my lock to separate with a password of 1, 2, 3. Then I'll connect each dial to one index. Dial 1 to the first index, dial 2 to the second index, and dial 3 to the third. If I playtest and rotate the dials, you'll see on the display the numbers they output when I release the dial. Here's a few important points. You cannot set an output value for turnables, dials, and slidables. Instead, the player interaction will determine the value sent. Turnables, dials, and slidables are 0-based, so the first step outputs 0, the next step outputs 1, and so on. For example, a turnable with 8 steps will output 0 to 7. A turnable with 100 steps will output 0 to 99. If you're making a letter lock with 26 letters, A to Z, even though N is the 14th letter in the alphabet, the dial will output 13 if set up correctly. Just remember to always use a display to confirm that the password you set for your lock matches the password displayed when the player solves the puzzle. Just a note about slots. You can set up slots to send outputs to a lock the same way as any other event, but beware of passive zeros. When slots become empty, they will send a 0 to connected locks. For example, if you're using one match to light 3 different candles, you might expect a password of 111, a 1 for every slot. However, because you are removing the match afterwards, it will send a 0 back to the lock. And that means that your sequence password would actually be something like 101010. Again, remember to always use displays to see what your lock is reading. Activators are used to enable and disable the following prop properties. Object affects all properties of the prop, essentially making it not exist. Unchecking object reveals the following sub-properties. Usable. Disabling usability effectively removes all behaviors from props and disallows interactivity. The player will not be able to pick up, press, move, or interact with the prop or any of its children, and slots will be disabled. The following options target the prop itself but not its children, which must be targeted separately. Renderer controls the visibility of the prop. Collider. While this also controls usability, this prevents props from occupying physical space and mass, like other items being thrown or rolled through them, and whether item respawners and triggers are functional. A prop that uses physics will fall through the world without a collider. Obstacle determines whether the prop blocks the player's movement. You can set your activators to be active on start of the level or trigger them on demand through other events. You can enable, disable, or toggle between property states. Wherever possible, use dedicated enable and disable activators rather than toggle. For something simple like a light switch, toggle might be fine, but in most cases, it's best to issue clear, purposeful actions so you can always know what result to expect. The collider is an invisible prop that defines physical space, what the player can touch or click. Colliders can be used to enlarge the hitbox for a prop that's too small, like adding a large collider as a child to a tiny button. You can also block the player from accessing another hitbox underneath. For instance, covering access to a control panel until another puzzle unlocks. Just note, if a player can walk into a collider, they can interact with items through it as well. Keep colliders as large as needed but as small as possible, and add an obstacle to physically block the player when needed. You can also use colliders to prevent players from throwing items out of windows. You can rebuild colliders for props where the original collider doesn't work for your use. For example, if you have a box that doesn't let you place items inside, you can turn off the box's native collider with an activator, then add new colliders to the sides and bottom of the box as children. Item respawners react to any props marked as keys or hints that enter their 3D space, much like a trigger does. When a key or hint item enters, you can choose to return it to the player's inventory, return it to its starting position in the world, or respawn it at the location of any empty you've placed. Item respawners are useful for resetting puzzle elements or preventing players from losing important items. You can choose to respawn the item with physics enabled if you want it to take gravity into account. The script prop is used to link Lua script to your level. For more information, see our video on Lua. Roulette logic allows you to add random events to your room. Select which props your roulette should target. Choose whether props can be targeted more than once, and set a testing target for playtesting your setup in the room editor. Each time a roulette is targeted, it will randomly activate one of its target props. This is great for something as simple as adding variety to repetitive button sounds, or even something as complex as randomizing puzzle solutions. Puzzle logic controls your walkthrough, tracks player progress, and manages competitive events in versus mode. Place one puzzle logic for each puzzle in your room and give it a clear name. Open the Settings tab and then walk through to write your puzzle hint sections. Give each section a puzzle name, then add progressive clues that guide the player towards the solution in the last hint. On your puzzle prop, click Hint to link it to the corresponding section in your walkthrough. You can connect it to any precondition puzzles that must be solved first. This walkthrough section won't appear until its precondition puzzles are complete. Puzzles without any preconditions will always display their hints. When a puzzle is solved, trigger its puzzle logic to mark it as complete. This will remove that section from the walkthrough. It will unlock any walkthrough sections where it was a precondition. It will play a sound, unless you check the box for mute. And in co-op or versus mode, it will display something like Player 1 has solved Puzzle 1 on the screen. In the room editor, this message will always display to you for testing. Leave the puzzle name blank if you do not want a message to appear on the screen. The open link logic can be triggered by a button, allowing you to open a web link in the Steam overlay. Links are restricted to the Steam Workshop, the Steam Store, or Wikipedia. This is most often used to direct players to your Steam Workshop, link to discussions or guides on the Steam community page for your room, or reference a Wikipedia article for a puzzle that needs external knowledge. If you want to share a YouTube walkthrough for your room, post it in a Steam community discussion first and link to that discussion instead. And finally, and in some ways most importantly, finish logic. You must target a finish logic to have your player officially complete the room. You can also choose a camera angle for the player to capture a souvenir photo. That's it for this one, guys. It was a long one. Locks are the most complicated part of the room editor, but if you made it through this one, then the rest is a piece of cake. See you in the next video.